Yeah, so he might not be.
Okay, so
Or maybe he will just join us a little bit later.
okay,
Yeah,
so let's start then. Um, I need to share the screen.
yeah,
Yep,
that's a little bit. No,
cool. There we go. All right. So is everything clear?
yeah, very
Okay.
nice. Beautiful green.
Yes. I like it high contrast so I don't
Yeah,
forget
that
about
worked well.
everything.
Yellow and green work really well.
Cool. So basically I finished uh reading this kind of article from the author of Daniel, the author of Shake Uh, actually, say
Ah,
Code.
yeah,
Yeah.
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 Well,
So
I usually brown as well. But
yeah, yeah.
yeah, this
So
is a curling, sport.
oh, interesting. Is that the
On ice where they have this
It's like it's like you are doing cleaning.
yeah, actually they use brooms to make sure that the ice has the right consistency. The little thing that floats, I can't remember what the name of the thing is, that actually goes slower or faster depending on what they do with the broom on the ice. So it's
Yes.
not the touch the thing, but you can touch the ice. Yeah,
Ah,
so it's funny. It's yeah, very funny sport.
yeah. It looks like you're just Olympic for cleaning. Like who
Yeah,
cleans better?
the ice is very clean.
Yeah. So yeah. Cool. Okay. Cool. So this Swedish guy exposed a lot of the problems of the CVE.
Yeah, but this is the video being sent us, right?
Yeah.
Yeah.
So he also documented all the conversations between the core project and the CVE and MITRE. He also sent out the video yesterday. It's
Oh, okay.
breathly baked.
Yeah.
He did a talk on a conference, but he
Yeah.
didn't record it. So recorded it again. And yeah, so basically, the main takeaway here are the 4 points
Mhm.
in his own words. The first is full of questionable content and plenty of downright lies. That is the case because, like, in last year, that would be 2023. Yeah, he received this CWE 2023 52071. So the irony here is, the guy who submitted this was anonymous, so no one knows who submitted it. And also, it's just weeks before like their team become the core team become CNA. And then he exposed that the CVE program, you are basically next to impossible to get rid of invalid CVEs. I think he made a really good argument in saying this. So the whole program is designed for good faith reporters against bad faith product organizations. So the reporters are automatically assumed they are good, like they will not do evil to the system. And apparently the vendors, the same A's are assumed at fault by default. Um, and then there is also a lot of bureaucracy involved. Um, so basically, the whole thing organized, the whole CVE program has root CNAs. They are considered their officers. And then you have member CNAs. You submit to it, and then the program just give you a email saying, okay, you're part of the program now. Now you are CNA. Now you can assign members to vulnerabilities. And yeah, so if you are a member of the CNA, you cannot really talk to the MITRE group or the CVE program directly. You have to go through your officers. And this could be really slow. Yeah, in the case of the core, is the Red Hat, they're root CNA. So they talk to the root CNA, the Red Hat, and then the Red Hat talk to the MITRE, and it's the whole conversation is made in the way that the MITRE group almost doesn't want to talk to them. So there's no transparency in their decisions, like why it's a problem. And when they are kind of talking to the MITRE group, the MITRE group responds with, okay, I just don't want to piss off the reporter. That's basically the whole rationale. Yeah, so apparently you can easily sabotage the whole system by just using a generative AI, use a ChatGPT, say create this CVE for me, and you can generate tons of CVE and just put it into the system automatically. You would receive at least a disputed status. So yeah, so the disputed tag is if one party disagrees with another party, then it's automatically disputed. Even though it can be a bogus CVE. So the whole system is running slow because of this. There's a lot of bogus CVE, a lot of credit seekers.
Well, it actually happened.
Yeah, it's happening right now.
Do you know why?
There was another paper criticizing this, saying basically we call it credit seekers. So for example, if I want to be if I want to work for Google's security team, the first thing they ask, or the first thing you want to show is I have numerous CVEs. I have found plenty of them. And you could give them, actually one of Wimo's students, Michael, that was an interesting story. He's from Taiwan. So the first day I get into the lab, the US embassy visited us. At the embassy, he was like going around like, okay, introducing each other. And then while Michael was in front of me, and then he introduced him, he kind of introduced to me as well. So I was like, I'm from China. And then he remembered that Michael is from Taiwan, and he talked to us in Chinese, saying, "Oh, so you guys are good friends." Yeah. So he actually found a CVE as a master, so it's quite impressive for the time being. And I remember Wima was pretty excited for a whole month. I keep bragging about it. Yeah, so it's quite impressive work to get a CVE. So that's reason one, and then reason two actually uh, backed up by the other paper I found. So something like Google Project Zero. So basically they put a security team from a bigger company. So imagine you are a smaller company with a newer product like a ChatGPT, and you are Microsoft. You would put a security team on the ChatGPT product just to expose their vulnerabilities. So that you get a warning while as an end consumer saying this product is not secure. And as an end consumer, you don't know much. All you do is find alternatives. And then you find Google Copilot, find other stuff. So that's a vicious circle within the business domain that is also happening right now, which has been criticized as being unethical. because you are basically bullying smaller company are bullied by the bigger companies. Yeah, so here are the two major reasons why there are many bogus CVEs. Sometimes, yeah, sometimes it's actually almost encouraged to have such CVEs. One of the hidden doctrine is uh, actually stated as in the paper. They're basically saying this is the only way to push the product to progress. Even though I don't really agree. It's like you can rationally give a time window and negotiate about it instead of putting things out and force people to change. Otherwise, I just give hackers free access. Yeah, so you have a product to run that way. So yeah, here are the two major reasons that I found in two of the papers. Oh, hello, Wilma. Yeah.
Hello.
Sorry, I was late. I came back from a class and then I was pulled into a secret meeting.
Oh, nice.
Yeah, that's the episode we're about.
Yeah.
I hope you have not been overloaded with additional stuff to do. It's a result of the meeting.
Um, it's a short to medium term thing. I have stuff to do, but not right.
Gotcha.
Okay.
Yeah, so we were talking about Michael, and we were talking about why people are doing CVEs, like how it's impressive. So basically, last week I found this blog from the author of the core project.
You did mention we had. I remember discussing it with you.
Oh, this is new. The
Okay.
one that we discussed was the Project Zero from Google.
No. We had talked about because he had an issue with CVE where some library was reported as being spyware or something, right?
Oh yes. Oh yes. That was way back.
Yeah.
Yeah. Now there's a new one.
Oh, okay.
Yeah. So that one was back to the 2020.
Right.
Now there's a new one, 2023.
Okay.
So basically he made a new video, kind of a channel in YouTube, and he's exposing this. He hand out all the conversations between MITRE and the core project, and he's complaining how uh, yeah, how the system is kind of crooked.
So this was the link yesterday about the 6 and
Yeah,
Yeah. From
you seen the email? I sent out a link about
yeah,
it.
yeah. I think I've seen this.
Yeah, and day before yesterday, he made a video as well.
Okay.
So it's at the end of the second link. So if you click on
I
that,
don't think have the I don't think have the YouTube.
oh, interesting. Yeah.
Yeah.
Yeah, so he basically uh, did a talk on conference, but he didn't record it. So he ran through the slides again and put it on YouTube. Yeah, so yeah, that sounds like him. Yeah. So I think there's a really good point that he mentioned. This whole system is designed for the good faith reporters against bad faith vendors. So automatically that leaves it vulnerable to credit seekers. So I can just submit tons of bogus CVEs. You cannot really remove them. And yeah, we were talking about how could, like, what are the motivations behind it. So personal gains, you can become famous within the domain with many CVEs, and you can easily get jobs as a security analyst. The second being the bigger companies can bully the smaller companies with tons of CVEs. Yeah, so yeah, basically that's where we were. Yep, so I think this is a good point in the sense that to the paper, it mentioned that there's a lot of questionable content. And some of them don't even have good enough descriptions and all that. So that's what we need. So I have put that down into my paper. Let me show you real quick. Blah, blah, blah. Yeah, this is. So last week I reframed the eval paper into a chapter. I haven't finished everything. Mostly I was working on the problem statement, and I did some search around CVE descriptions, and then that guy popped out, so I looked into it, and it turns out it's highly relevant and pretty new. So I mentioned that in the problem statement. The author of this, here are the points. Basically, a lot of questionable content. Next to impossible to get rid of invalid CVEs, bureaucratic and intransparent, and utterly designed for the good faith reporters against bad faith vendors. So basically, anyone can submit a CVE with an anonymous account without any verification of the identity. And then I start to talk about the how the NVD recommended templates and how it's not really followed. I gave the example of the finger.
Look,
Yeah.
the thing is, with his one issue that I have with his comment that we have, okay, so there was an issue, now we fixed it, can we, remove the name, remove the vulnerability? Well, we shouldn't remove the vulnerability. We should
Yeah.
remove it because what there may be people who may still be using an older, code base. which
Yes.
has so yeah, you fixed it, great. And that's the point of PVE, right? Once you did that, it urges you to fix it. You release a new version and hopefully push the version and people will pull the new version and start using it. But the point of PVE is not that if you fix it, that it should be removed from the database.
Yeah. It on the premise that the CVE is valid. So if there's indeed a problem and the project maintainers fix it, then it could be there. I totally agree on that one. But he was more like, what if the CVE is bogus? We don't have enough information, and the whole system is paralyzed on what to do, and they just put a disputed tag there, and then the whole system has a lot of false alarms on the product. So I think that's why he's really mad at the whole system, which is true because I noticed a lot of disputed CVEs. Just nobody's gonna look at it again.
Okay.
Yeah. So, in his words, the whole CVE program is for the good faith reporters. but the MITRE corps did not really have the energy to check the background of the reporters. So I think a better solution could be they only allow the CNAs to report it. And then it defeats the purpose of the kind of a. So apparently the vendors doesn't want to say, oh, my products are vulnerable. It's almost too much of a kindness. Yeah, so then the whole system is fall back into a kind of a awkward position where you ask people you don't really know to do the serious work. So you have to trust a stranger kind of thing. So that's the problem. Um, or a better solution, which I'm kind of working on, is let's just make it all open source and transparent. So nobody is automatically assumed trustworthy and we can all criticize each other's work. That sounds more rational to this. We can all be strangers working against strangers. That's fine. We just peer review. Almost just like paper reviews. Yep. So yeah, so I took a deeper explanation to the problem. Basically saying our proposed like a natural language description analyzer as the first step to address this bad fit reporters. Almost like a syntax check to the descriptions. And of course, by no means we claim that this syntax checker automatically remove all the semantic errors. So basically, I state the limitations here as well. So in other words, we're basically building a IDE syntax highlighter, but for the descriptions. So while you are writing the description, I can highlight, here's what you have, here's what you're lacking. That automatically highlights what you need to do to make it better. So for the bogus CVEs, let's hope the kind of credit seekers don't have the money or access to ChatGPT. Let's assume they have fully written a lot of the CVEs, and then this automatically checks it out. Okay, here your report is not complete. We don't really know what to do, and it will become one of these bogus or disputed ones. Or even with the good faith reporters, let's assume they write up something but really carelessly. They forgot about the impact, they forgot about the root cause, and then we can inform the writer, okay, here's what you are lacking. You need to put this on, and that'll probably be more helpful to make the whole evaluation process faster, either by MVD or any analyst. Yeah, so I restated this, so it's more apparent in the paper. And then I split the examples into two parts. So basically, the first part is saying here. So what's the issue with the vulnerability descriptions in the CVE? So here are the examples that what can be the issue. Basically, you miss one or more essential aspect. And then with this one, I'm trying to say what's a good. No, I should avoid saying that. I should say what's the description that we ask the people to have. So we ask to have the full aspects. So here are the examples. Yep, and then I started looking into the few shot domain, and there are some interesting points I should put here. So basically, in the paper of GPT-3, they mentioned the power of few shot learning capabilities of large language models. But in my paper, I think I should point out what is a large language model comparing to a small language model. So there's an interesting research with OpenAI. So they're studying the size of the data, size of the parameters. But I haven't finished reading the paper. It's very technical. Yeah. So in short, the conclusion is with smaller data sets from 10 to 100, you can invoke the power of LLM, large scale language models, to do the meta learning, or in their words, in context learning. So basically, the model adapts to your task. The model figures out what you are trying to do. So that's what we are basically trying to achieve, because we only have 400 some data sets. So therefore, I think I should reframe the whole paper into a few shot learning setting instead of fine-tuning setting. With the fine-tuning setting, the data is apparently insufficient. It's not large enough to make the model sort of learn and generalize. But I put that as a future work. So for example, increase the data set. The future and more engineering-oriented work can help improve the performance and the generalization ability of the model. So basically what I'm saying, with the evil data we have, it's already like 70% with the labeling, and that's few shot learning, or rather model fine-tuned on a few examples. So if someone in the industry increase the data size, I can easily imagine it can be increased to 10,000 within a month with a team size of 10, something like that. It will have more potential. So I think that's the point I'm trying to make here. So if future learning is already impressive, if you do a fine tuning, larger scale, it's going to be more impressive. Yep. So that's the work I have done so far. So I sort of refine the problem statement and introduce some more concepts. And any comments so far? Or should I continue?
So with that, how does that affect the output of your work that are already there?
The experiments would be the same, but the presentation would be better in the sense that I explicitly saying there are limitations here. Look, it's not good enough for production. It's just more like a proof of concept, academic work. In few short
And the
learning.
more data you have, the better you get.
Yes. So that's basically
Yeah,
the difference.
yeah, like that.
Yeah. So and also I realized I need to read more into the few short learning in NLP, because there is a lot of work related to answering these questions, like what's the best model for fine-tuning and few shot learning, and how the few shot learning performance compared to the fine-tuning, or some work even, do we need fine-tuning anymore? So if you have so basically the argument is, if you have a really powerful model, you can figure out what you're trying to do with a few examples. you can probably just do everything online. You don't need to put everything offline, fine-tune it. So that's what the artificial general intelligence, what they are about. Yeah, so there's a lot of work in that. So I have been reading this. Basically a lot of works from OpenAI. So it should be this one. Yeah. So basically the GPT-3 paper, actually that's the free model. Actually, no, this model is already dated. So they have the Omnium one. But this is the model before this one, like what we are using for ChatGPT right now. So they define a task called in-context learning. The big idea is you can sort of invoke the meta-learning power within the large language model. In other words, the model more or less learns a general intelligence to adapt to a particular task. So, and they also give the data amount you need to invoke this power. So right now we're looking at from 1 to 10. You can do few shot learning. So to fully kind of activate this, you need something like 10 to 100 examples. That's actually what we have. So what we really should say is this: we have done the few shot learning, blah blah blah, and I can also do more tasks on different models to see how they perform in a few shot learning setting. Yeah. So in short, if the few shot learning is good enough, the fine tuning will only be better. So, and they also explicitly saying the result of few shot learning is far inferior to the fine tuning. So in other words, yeah, you can do much better with larger data sets with fine tuning. Yeah, and then I'm still reading the weakness of GPT-3. So basically they're saying there's some times repeating themselves. Yeah, I think we all know about this. Yep. It's a really long paper. I haven't finished reading the whole thing. And then there is something they mentioned in the paper. So they were saying, so basically my question was, how many examples should we have? Like which model should we pick? Because how do you define a large language model? Like what's considered a large language model? What's considered a small language model? So there's no clear defined lines. So, but they mentioned this paper, but scaling laws for neural language models. So I haven't finished this one, but the whole point is basically examining the parameter size, data size, the computational power to define the trade-offs. Yeah, so that's what I have done so far for the last week.
This paper, like a big example, this is from 2020.
Yes.
2024. I think models have large.
Yes. So you could be dated.
You might have to adjust.
Yeah.
So, yeah.
So after this one, I will also look at the 2024 papers, like that are citing this work. So they probably improved upon this. Yes. So what I hopefully could find will be like the definition of a large language model. the definition of a large data set or small data set. So then we can put that into the paper saying, okay, which models are not large? Because people are confused with overfitting and all that. I think that's because of the definition of the large language model, and language model in general is not distinct. So we need to split the two and hopefully make a clear definition. Yep. So that's all. And they do some fancy mathematics. Yeah. Yeah, luckily I got a background in PDEs and stuff. So those are actually quite easy. So yep. So for the next week, I will continue to work on the few-shot learning stuff. So I will add some more findings from these papers, and then put together, I mean, at least probably the problem statement, and then the result and stuff just slap on. It should be easy. And yep, and also that's pretty much it. We got like 20 minutes left. Should we look into the reviews?
Yeah, sure.
Yeah.
I don't know. Within the time.
Yeah, so basically we were at this one. Yeah, so we pretty much finished this one. Now we start with reviewer 2.
Which paper is it? Is it the one, the conference paper?
The NSS.
Right.
Yes, the NSS. The conference paper, yes. The journal paper is pretty much done. We are waiting on their reviews. Yeah. So the strength, we skip that. So the same thing. So small data size. So I should really mention the few-shot learners. And I need to reframe the whole thing into a few-shot learning setup. Purpose model automatically description screening that it's not well explained. So basically, he's saying he's confused with the description quality screener. So the whole idea is because we know what are the good labeling from the evil labeling tool, we can use that to define a data set. So that we generate another data set from our label. So yeah, so this is basically the idea. So I think he's confused with why we are using this. But it's just my thing. So I'm thinking maybe we can mention because the evil model is too large to screen the whole thing. Then we need a smaller model with smaller overhead to do the screening. Then use the larger evil model to look into it. So I guess that's the whole point. Basically lightweight. And then the evil labels out description. Paper does not mention the distribution of good or poor descriptions or vulnerabilities that can impact the prediction results. And there is no mention of techniques to handle imbalanced data. Um, our data is actually imbalanced, is balanced because we created 150 of each.
Yeah, but I think you might be looking at when you apply it in the real world, the data still be balanced or would be unbalanced. So maybe that's
Yeah, that's the call. So, uh,
but remember, our power experiments be is the balanced power, but that probably already tells someone that the richer data the top ones, right?
yeah, the MED is not balanced apparently.
So you can train a model on the balanced data subset, but
Yeah.
I think what they might like to know is does the model then work quite well on unbalanced or would you have to do some specific balances?
Yes. So that's actually the problem. In the so basically in the findings, we filter out some of the good CNAs, like they write better descriptions, and some of the CNAs they are writing not as good, not as impressive CNAs because our model says so, not because they objectively are. So it's hard to double check this. So we need someone to go through the whole database and then say, yes, indeed, they are the worst writers. So we need something like that. That means I need to reach out to NVD and to asking them for verification. Could I do that? And then I can check whether the model works good enough on the imbalanced data set.
How do you balance your data?
So the data set I'm using is artificially created. So I labeled 450. So I from within this, I picked 150. And then I crafted a data set for the USE model, which is our lightweight model for the screening.
Yeah, it's tricky. I was wondering whether we could actually maybe simulate the balance over last nights, but we don't have to look at
Nope.
we instantly feel about a balance about maybe.
Yeah, the model will definitely be overfitting. Yeah, so it's basically a downsampling. I can, yeah, probably upsampling.
Yeah.
Uh, so that's actually solved the problem in a sense. So basically, the idea is we have bad descriptions. I can use a generative AI to just generate a good description based on the bad one. And then automatically we upscale the whole database to be balanced.
No, sorry. I'm not sure I understand. We want to check what happens if the data is if new data,
Yes.
model that has been trained with balanced data, what happens if we have new data that is imbalanced?
Yes.
Will it still perform equally well or will it actually be
Be worse. Yeah. So what I'm saying is, uh, we still need to balance the data, and or I can just do the experiment and say what's the difference. But the problem here is, we don't have ground truth for the large data set
Yeah.
because it's too much work to check out whether it's good or not. So we don't have ground truth. So what I was saying is, we can use generative AI, more or less promising the quality. But then it's also a questionable work. We need to check the quality of the generation. So we cannot get human out of the loop. That's what I'm saying. So for the
This, if so, you have you know that you get when
yes, yes,
you should use the model on all the unlabeled data.
yes.
See what it generates.
Oh,
And
what do you mean by the last sentence? Like generated?
what
Oh,
like using it for prediction of
yes,
say this is a good one or not.
yes.
And
Then we need to check 200,000.
verify the output.
Yeah.
So we could be looking at once a lot of confidence. And also we would actually correctly do.
Yes, we can do that. Prioritize this. Yes.
And this way it might be faster than manually loading.
Yes.
And so you could maybe this way get more data, labeled data.
Yes.
Then you could repeat the process. Okay, how many unlabeled?
Uh, 190 something. Should be 200,000 something now.
200,000.
Yes.
Okay. And you manually labeled 250, and then you have a model that is trained on them.
450. Yes.
450.
Yes.
Yeah, so if you apply that model to the 109,000 and just look at the, I don't know, 50 most confident good and 50 most confident bad ones, and see, something like that, but that might actually be a faster way to generate more data.
Yes. I can do that. So I can make it even more faster. So basically, I can use a generative AI to do the checking for me. But that involves I need to check the quality of that too.
Yeah, I mean, of course, this speeds it up and it's really reliable.
Yeah. And then this model is basically the answer. So if this model can determine the quality of the inputs, then this generative AI model is basically what do we need. Yeah, so there is confidence. I can look at that. I can also look at the. So the idea is I can ask I can ask ChatGPT even. Like here are three examples of good description or bad description. Here is another input that possibly I don't know is good or bad. Can you just explain what's going on? The model will generate something. Yeah. So that probably makes the job easier as well. I can mention that in this work.
So when you say, if you ask ChatGPT what the description is good or bad? What are the parameters of good or bad?
So we just explicitly saying it needs to have these four vulnerability aspects. So we need to introduce the model that whole idea. Here is the vulnerability aspect. Here are the four metrics you need to look into. And here's a good example. Here's a bad example. So after that, I can continue asking to, okay, here is a bunch of data. Look at this and explain which one is better, which one is worse.
I mean, that doesn't sound like a fair comparison, right? Because the model, they, the model, yeah, you can tell it what the vulnerability aspect, but it doesn't really know what it
Uh,
is. Because that's a concept that you have created, isn't it?
yes. So the whole thing is, if the model is large enough, it's meta learning enough, or in context learning enough, you should be able to tell, maybe not solve the problem, but more or less help the problem. So I think it's better explained with example. So for next week, I will do a couple, and then I will show you guys like how it looks like.
Yeah. I think my, yeah, that would be, yeah, you can show it by example and see how it performs. My intuition is that it would perform poorly because it doesn't really understand what you're trying.
Yes, with what they call the smaller scale language models, yes, totally. But the whole idea of the GPT-4 or the GPT-O, the Omni, is basically they have learned so many different tasks. The model learns how to figure out what task you're doing from a few examples.
Okay.
Yeah, so uh, the GPT-3 is already showing there's a few shot capability. And then the GPT-4 will be even better. So I can, um, yeah. Do we still have the Chat GPT access? I think
We have the account, but so we were paying for the premium one, right? So I think I stopped that because we stopped using it.
yes. So I can do something with the GPT Omni. So it will be something like this. Uh, right now I'm
No,
using,
no. The usage was based on how much the billing was based on how much you were using it.
yes,
Yeah. You can go ahead and do that.
yeah. So I think for a few examples, it could be like a few dollars, like one or two, something like that. So I can also do this with the Google's Gemini. There's also a new model. The Llama 3. There's also one from Facebook. So checking how that works for us. Yep. So both BERT and BART models would introduce significant computational overhead on training, tuning, and deploying, which require a lot of computation resources. The paper would benefit from a discussion on what are the trade-offs between scalability and efficacy, and how this would compare to the expected improvements on the CVE description accuracy. Are there other approaches that could achieve similar results but with lower resources? We need to retrain the model in the case of new type of vulnerabilities and different descriptions. That's actually basically why we have the screener. So yeah,
I guess in terms of the results, they just put that the savings.
yes,
That savings not that expensive. Yeah, you need to cheat to get it.
yes.
So then these guys, and yeah, it's kind of hard to believe it's scary. But I think it's progress in terms of you probably need to retrain every now and then.
Yes, for efficacy, yes.
We could speculate about the necessary and what not. And because if there are other approaches that are less expensive, basically, I think you answer would be no, right? Because
Yeah.
stuff compared to and other stuff, it might be faster, etc. They usually give you no resistance.
Yeah. I mean, unless we figure out a pattern, an easy to spot pattern, and feed that into a role-based system. That sounds like cheap.
Yeah.
Yeah.
But, so far you can't do it.
Yeah. Or I can probably. So basically, I can ask the model to explain, and then we'll see some kind of heuristics. Then we can extract that heuristics. So, but that sounds like a lot of work. Yep. So, yeah, I can look. Yeah. So to this, basically, we just say, yeah, we need to retrain this. So put this in our limitations. Yeah, actually, I was thinking that's basically true for all the language model or LLMs, large scale language models. We have to do it offline. Now, actually, Bernhard, do you know any online LLM that can do data
Online?
streaming? Yeah.
Not exactly. I know there's some work, ongoing work on continual learning LLMs that can be online or getting into more online.
Right.
But I don't think I've seen any explicit saying on that.
Okay. So ideally, if the LLM has a memory capacity adaptive to the inputs, then we can have a kind of a data stream based LLM. That could be cool. Yeah.
There's nothing that really sticks out. You've got a lot of picture language models, but nothing that explicitly says
Oh, there's
online training.
something I find here, not fully relevant to us.
Online training for large language models didn't happen from March this year. Learn while checking. So that could be interesting. I'll just
So they're calling this context-aware AI agents. Adapt a stream-based design. So I'll find one for the chain stream from mobile LLM.
But this one is not telling me that the model actually knows non-linearly.
Yeah.
Actually, producing genomic streams from shape H. Because they're not talking about training.
Yeah.
Whereas this other one that I put into the chat, that is visible about unknown.
Oh, nice.
So change to a bit. So it's definitely interesting to look into that.
Yeah, so technically, if this thing is deployable, ideally it should be online. Because there's a lot of reports. So if it's online, that'd be much better. And also, it sounds like a cool concept too. Online language model.
Yeah, at the end of the day, everything should be online.
Yes.
But occupied the power.
Yeah.
Mainly what because retraining is a reasonable for updating, fine-tuning is a reasonable challenge.
Yeah. Well, theoretically, if the GPT-3 or anything larger than the 70 billion parameters could have the capability of meta learning, or few shot learning, then you can just make it online. We have plenty of online examples and show them this is what you're trying to do, and then the model is online. Sounds like very intuitive.
Yes.
Yeah.
But be careful that you don't get distracted by it, because it's not really needed for your field, right?
No, it's not. It's more like a core project in the future.
Sorry, could be mentioned as future.
Yeah.
The future effect, right?
Yeah. We can say we can make this full model online and something be better. Then if it's online, then we don't need to worry about this for efficacy. It's more like
I think it's good to discuss this based arguments.
yeah. Yeah. So yep. So looks time. So we shall continue next time for the reviewer 3 and the last half for reviewer 2.
Let's do that.
Cool. Thank you guys.
Yeah, good stuff. We'll see you next week again.
All right. Bye bye.